Okay, here we look at partial variation. And partial variation consists of two or more parts added together. For example, it could be that S is partly constant. That is, if something is constant, it means it's equal to a constant A, for example. Or it could be that S partly varies with another variable T. So that when I remove the sign of variation, I will introduce a constant B in this case, so that S equal to B T. So this is partly constant for the first statement, and then this is partly varies directly. This is direct variation in this case. So that by the time I add these two, I'll have an equation S equal to A for partly constant plus BT partly varies with. So this is an equation for the statements of partial variation. We have an example here. It's a tennis club has a machine that serves balls to practicing players. The machine serves the balls at a speed that is partly constant and partly varies at the time of flight of the balls. When the ball has been traveling for half second, its speed reaches 128 km per hour. When it has been traveling for 1/6 seconds, its speed is 46 km per hour. Find the speed of the ball when it has been traveling for 1/2 seconds. So let's use this equation so that S equal to speed of the ball and T equal to time. So that the question says the tennis club has a machine that serves ball to practicing players. The machine serves the balls at a speed that is partly constant. The speed is partly constant and partly varies as the time of flight. Partly varies as the time of flight t of the ball. When the ball has been traveling for 1/2 seconds, its speed reaches 128 equal to A plus B times 1/2. I'm substituting now because they say when a ball has been traveling for half second, half for t time, the speed reaches, the speed is s 128. So 128 equal to A plus half B, which I can write as 128 equal to A plus half B like this. Let me call that equation 1. Then, when it has been traveling for 1/6 seconds, its speed is 46. 46 equal to A plus B times 1/6, which I can rewrite as 46 equal to A plus 1/6 B. Let's call this equation 2. Now solving equation 1 and 2 simultaneously, let me write them here. The first one says 128 equal to A plus half B. And the second one, 46 equal to A plus 1/6 B. I want to use elimination by subtracting equation 2 from equation 1. A minus A is 0, then 128 minus 46. 1/2B minus 1/6B. Just by saying B/2 minus B/6. LCM of 2 and 6 is 6 itself. 6 divided by 2, 3 times 3B, and 6 divided by 6, 1 times is 3B minus B is 2B. 2B over 6. So 82 rather is equal to 2b over 6. Now cross multiply 2b will be 86, 82 times 6. B therefore is 82 times 6 over 2. 2 here 1, 2 here 3. B is 82 times 3, which is 246. So the time the variable rather B is 246. Now we need to find the value of A now. Solving for A. Using equation 1. Equation 1 says 126 is equal to A plus half B. I say 126, 128 equal to A plus half B. 128 equal to A plus half times B is 246. 246. 128 therefore equal to A plus 2 here 1, 2 here 123. A equal to 128 minus 123. A equal to 5. So A is 5. Now that we know the value of A and B, we can solve the question which says find the speed of the ball when it has been traveling for 1 over 3 seconds. So again, we go back to the equation. Let's clean this board first. So the question says find the speed of the ball when it has been traveling for 1 over 3 seconds. Now speed is equal to A plus BT. Now we know A to be 5 and we know B to be 246. So that is 5 plus 246 times 1 over 3, which is 5 plus 246 divided by 3 is 82. 5 plus 82 is 87. So the speed is 87 kilometers per hour. Question 2, 35 to the process, says C is partly constant and partly varies as M. C is partly constant, let the constant be A, then partly varies at M, let the partly varies will be Bm. In other words, when you say C is partly constant, C is equal to a constant A, then partly varies as M. When I remove this variation, I will introduce a constant B, then M. Combining these two equations, I will have C equal to A plus B, M. So now, if C is 45 when M is equal to 10, and C is 87 when M is 24, find the equation connecting C and M. This is the equation connecting them. Now, finding the value of A and B. Say C is 45, meaning 45 is equal to A plus B. What is M? B times 10. 45 is equal to A plus 10B. Let's call that equation 1. And C equal to 87, that is 87 equal to A plus, when M is 24, putting 24 rather here, that will be 24B. Let's call this equation 2. Solving equation 1 and 2 simultaneously, I'm using elimination, this minus this is gone. Then 45 minus 87, 10 minus 24 is minus 14. Minus 14B. Minus will cancel minus. Divide both sides by 14. 42 divided by 14. 42 divided by 14 is 3. Solving for A, using equation 1. Equation 1 says 45 is equal to A plus 10B. And we know B to be 3, therefore 45 is equal to A plus 10 times 3. 45 is equal to A plus 30. A therefore is equal to, I'm moving 30 here, that is 45 minus 30, which is 15. Then, excuse me, the question B says find C when M is equal to 18. You know that C is equal to, go back to the equation, A plus BM. We've known A to be, what is A? A is 15. 15 plus B is 3. 3M. This is the equation connecting C and M, which is this question here. Then B says find C when M is equal to 18. C equal to 15 plus 3 times 18, which is 15 plus 3 times 18 is 54. 54 plus 15, that is 69. A number P varies directly as Q. P varies directly as Q and partly inversely as Q squared. Now, for this first statement, if I remove the sign of variation, I will have a constant A. And in this second, if I remove the sign of variation, I will have a constant K. I just choose to use A and K. Combining these two, I'll have P equal to AQ plus K over Q squared. This is for varies directly, partly, varies directly as this rather, and partly inversely as this. So given that P equal to 11 equal to, when Q is equal to 2, 8 times 2 plus K over 2 squared, and P equal to 25.6. Let's work on this first, meaning 11 is equal to 2A plus K over 4. Let's call this equation 1. Then, and P equal to 25.16. 25.16 equal to 2 when Q is 5. That is Q of, that is 8 times 5 plus K over 5 squared. 25.16 equal to 8 times 5 is 5K plus K over 25. Let's call this equation 2. Solving 1 and 2, we have, let me rewrite them here. The first one says 11 is equal to 2A plus K over 4. That is equation 1. Then equation 2 is 25.16 equal to 5A plus K over 25. To eliminate A, let me multiply this equation by 5 and this equation by 2. So 5 times 11 is 55. 5 times k is 10a. 5 times k over 4 is 5k over 4. 2 times 25.16, 50.32, 0.32 equal to 10a plus 2k over 25. Subtracting equation 2 from equation 1, this will be gone. Then 55 minus 50.32, 4.68, 4.68 equal to 5k over 4 minus 2k over 25. Let's solve that fraction here. 5k over 4 minus 2k over 25. Okay, so LCM of 4 and 25 is 100. 100 divided 4 is 25. 25 times 5, 125k. 100 divided by this is 4. 4 times this is 8. 8k. 125k minus 8k. 117 over 100. You have 117k over 100 cross multiply. You have 117k equal to 4.68 times 100. K therefore is 468 over 117. K is equal to 4. Now that we know K, we can find the value of A using any of the equation. I'm using equation 1. We're solving for A using equation 1. Equation 1 says 11 is equal to 2A plus K over 4. 11 is equal to 2A plus K over 4. 11 therefore is equal to 2A plus K is 4, that is 4 divided by 4. 11 is equal to 2A plus 1. 11 minus 1 is equal to 2A. 10 equal to 2A. Divide both sides by 2. A is equal to 5. So we know A and K. Now we can find, the question says calculate the value of P when Q is equal to 7. We'll go back to the equation. What is the relationship? P equal to AQ plus K over Q squared. AQ plus K over Q squared. And Q given now is what? 7. Therefore, P equal to A is 5 times 7, which is the value of Q given to us. K is 4. That is 4 over 7 squared, which is 35 plus 4 over 49. This is over 1. Solving this fraction, LCM of 1 and 49 is 49. 49 divided by 1 is 49 multiplied by 35. 49 times 35 plus 49 divided by 49 is 1. 1 times 4, which is 1715 plus 1 times 4 is 4 over 49. 1715 plus 4 is 1719 over 49. 35.1 approximately. 35.1.